All right, good afternoon, y'all. So, so today we're looking at solving rational exponent equations. Um, and it's very similar to solving square root and cube root equations. There is one little thing you have to be careful with that I'll show you here in a second. But and if you hear any noise in the background, I do apologize. It's my boys. They're watching TV. But anyway, so the first thing I want to kind of show you is this. This is actually going to be a different lesson as well down the road. But um, we've talked about the square root of x and we've talked about the cube root of x. But the one thing I do want to let you know and make you aware is the fact that the square root of x can be written with what we call a rational exponent. So this is what we call a rational exponent or a fractional, depending on how you uh, look at it. Um, I can't spell all of a sudden. And essentially, just basically means that the exponent is a fraction. Okay, so that's kind of the first thing I'm going to kind of point out there. But the square root of x can be written as as x to the 1/2 power, just like the cube root of x can be written as x to the 1/3 power. Okay, and if you want to take it one step further and keep going, if you had a fourth power, that would be the same thing as x to the 1/4 power, so on and so forth. Okay, so that's the one thing I want to point out first. And the reason why this is important to know is because the one thing that you're going to deal with is having to, in this case, not only square root a number, but basically we're going to have even roots. And the one thing about even roots is the fact that we have to have plus or minus values. And to kind of just show you that, what I mean by that is this, that if we took the square root of a -4, for example, we would get imaginary type numbers. The same thing applies if I took the sixth root of a -4. And again, you still get the fact that it's imaginary numbers. So we have to make sure we account for plus or minus on the even roots of a number that we actually take. Now, most of the time, we're going to be dealing with square roots. So, and I'll show you how you know this in a second. But that's, what something I do want to point out now. So when I tell you that we need to check both the answers, we want to make sure that we do that. Now, the next thing I want to talk about is reciprocal values. And all of a sudden, my camera doesn't want to focus again. Something about technology sometimes is technology does not like to cooperate. But reciprocal values or reciprocal numbers essentially is that if I had 3 over 2, the reciprocal to 3 over 2 would essentially be 2 over 3. Okay, you're going to hear me use this word a lot, reciprocal numbers. If I had 2 over 5, reciprocal would be 5 over 2. If I had 4, reciprocal of 4 is 1 over 4. If I had 1/3, reciprocal of 1/3 is 3. Okay. Now, the reason why I'm doing this is because what I want you to notice is the denominator values. Okay, this one would be over 1. These two are even roots, which means that I would have to check for 2 answers, which means it's plus or minus, whereas the odd roots don't have to worry about that too much. Okay. All right, so here we go. So a couple of steps, a couple of things. How do you get the steps? So first thing is very similar to what you've seen before. Notice that there's a C over D now. We're going to move your K value. We're going to move the A value. We're going to do the reciprocal of D over C in order to clear the C over D one. And we're going to make sure the denominator of C is even, whether it's even or not. We'll move the H value, we'll move the B value, then we're going to check for extraneous again, because again, if it's an even root denominator, we want to make sure that the answer you get actually does work in everything. So that's what we're looking at for fractional exponents. And again, you'll hear me use the term fractional and rational exponents of what we're doing. Okay. So here's how it works. Oops. Let me kind of scoot this up a little bit. Here's how it works. In order to clear this, x to the 3/2 is equal to 27. I got to make sure that there are no, other values to work with. In this case, this is a basic one. So in order to figure out what the value of x is, I use the reciprocal value of 2/3. Hold on. 2/3 to both sides. Kind of like that. And that's not coming out very well, so I'm going to switch pencils here. Okay. And when I do that, what I'm going to end up getting is 27 caret button, and then my fraction of 2/3, kind of like this, and I get the value as 9. So you understand what you're actually doing is you're taking 27 squared, and whatever answer that is, you're taking the cube root of it. Wow, that's not coming out very well either. Let me get a darker pen. Okay, so let me write this out a little bit better. 2/3, 2/3, so that x is equal to 9. Okay, and again, what you're really doing is you're doing 27 squared to the 1/3 power, which is the cube root. So in a calculator, you could essentially do this. If instead of doing 27 to 2/3, you could go 27 squared first, and then raise that to the 1/3 power instead, which is 9. So either way works, however you want to do it. Okay. On example 2, if you want to try this one first, go for it, and I'll be back here in a second. Okay, so this is what you get. Now, I do forget to do one thing the first time. One, I did forget to check if my denominator was even. In this case, my denominator was 3, so that didn't matter. In this case, my denominator was also 3, so that's not too big of a deal. So that way, when I check my answers for extraneous, if I did 9 raised to the 3 halves, I should get 27, which I do. Okay. Now, on these, you have to be very careful with, and there are a couple of ways you can do this one to make sure the answer you get works, is I could do 4 times 3.302 raised to the 3 halves again. And I should get really close to 24, which in this case I do. If you do 3 decimals, you should be very, very close to what this is. Okay. I could also do this. I could really use this answer that I started off with here to get the same thing that I wanted. So if I did 4 times 6 raised to the 2/3 raised to the 3 halves, I should get 24. So either one will work. If this is correct, you'll be off by a little bit. If I take this 3 decimals out, usually that would be enough to kind of determine whether it's true or not. Okay. Okay. So now number 3. So this is where it starts to get a little bit tricky, that you have to be careful with. Okay. So the first thing is I have no K's or A's to mess with. So the next thing I want to do is I want to go ahead and take this to clear this 2/3 out. I'm going to take this to the 3 halves on both sides. Kind of like that. Okay. So here's what's going to happen. Because this is an even root, basically it's saying 25 to the 3rd power and then taking the square root of that. Since I'm taking the square root, let me write this again so you can kind of see it. Okay. That's the number I care about. I have to make sure to include the plus and the minus of the actual answer. Okay. This will go to 1. So that way this becomes -1 minus 18p. So when I do 25 and I raise it to the 3 half power, I get 125. But again, because the fact that my denominator is a 2, which is an even number, I have to consider positive and negative 125 on this one. So plus or minus 125 because of that. So this is because it's an even root. And that's going to be equal to -1 minus 18p. So now I'm going to actually have to get 2 answers on this. And I should have separated this differently, and that was my fault. But essentially, I have this one. And let me write this over here. I should have separated this differently. Where I have -125 is equal to -1 minus 18p. So then, I add one here to get 126. And that's going to be equal to negative 18p. So p on the first one is going to be equal to, divided by a negative 18, negative 7. And then here, if I add 1 and I add 1, I get a negative 124. So negative 124 divided by negative 18 gives me a positive ugly number. That figures, right? So in this case, I'm going to do and get a fraction where p is equal to 62 over 9. Okay, so the answer I got originally was 6.888 repeat. Okay, so I'm looking at these two numbers. So what I do now is I go back to my original equation and I check to see, okay, which ones actually work. So if I do negative 1 minus 18 times negative 7, and I raise that to the 2/3 power, hold on. There it goes. I have to fix my calculator. Then I get 25. So that one's good. Okay. And if I do the same thing for the second one, so negative 1 minus 18 to the 62 over 9, to the, was it 2/3 power again? I get 25 again. So both of these answers work. And I have two answers I have to consider on these. Okay. So try number 4. It's kind of the same way. I'll be back in a second. Okay. So here it is. Again, I subtract 3 first, both sides. Divide by 4 to get 0.5 or 1/2. Then you take the exponent to the negative 6 over 1. Yes, you keep the negative. You want this to become a positive one. So negative 6 over 1. And 0.5, so that should be a 64, which is equal to A. And then when I check it to be sure that it actually works, I get 5 again for my answer. And that's good to go. Okay. I'm looking at the next ones already. So look at the next ones. I'm going to try them first. Go for it. This is supposed to be a minus 10. That was just a typo on my part. Okay. I'll be back with this one in a second. Number 5. By the way, number 5 is a lot like number 3, just letting you know. Okay, here's number 5. And again, I subtracted 10, get negative 16. Divide by negative 1 to make it a positive 16. Then I take this to the 3/4 power. 3/4 power. And again, because there's a even root, which is the 4th power here, or 4th root, then I got to make sure and get two numbers, which becomes 8, in this case, negative 8. Okay. Now, if you're not sure how I got that in the calculator, I just essentially went 16 raised to the 3/4 power, and I get an 8. So 8 and negative 8. So I have x minus 10 is equal to 8 plus 10 plus 10, which is 18. X minus 10 is equal to a negative 8 plus 10 plus 10, which is 2. I checked both my answers. They both give me negative 6, which is what my original answer was to begin with. So both of these work, and I have two different answers on this one. Okay. Hold on. So again, there's number 6. If you want to try it, I'm going to pause it here, and I'll be back in a second. Okay, here's number 6. So again, so add 6 to both sides, divide by negative 5. Then I reciprocal 5 over 3 to 3 over 5. 5 is an odd, so I'm not worried about the other number here. We get 64, subtract 22, get 42, divide by 3, get 14. I check my answer, and my answer is the same as I started with, so 14 is the right answer. Okay. Okay. So one of the things you see a lot of these in, or especially in geometry with area and volume formulas. So the one word problem that I'm going to just kind of show you does that itself. There's your area formula here, where area is in centimeters squared. You want the average radius is r. So what's the average radius if your area is 112.5? So again, if I set it up, so 112.5, which is equal to pi r to the 3/4. Okay. So in this case, I'm going to divide by pi first. So I'm going to get and I'm going to show you something else. Because this is pi, I'm not going to actually do anything with this yet. So what I'm going to do is I'm going to take this to the 4/3 next and I'm going to take this whole thing to the 4/3 power. And what that's going to do, it's going to give me the average radius that I'm looking for. Okay. So when I plug it in, I get 112.5 over pi raised to the 4/3 power. And I get to the average radius is about 118. And to the nearest tenth is, well, in this case, 118. Okay. 118 centimeters is the average radius for this. Okay. And there it is. And if you want to write, you put 0.0, that's fine. It's not going to make much difference. So there is fractional, rational, or rational exponents, depending which one you want to say. So we'll see you around, and yeah, there it is.